In this video, we'll look at a whole lot of different application areas of IoT to engineering. Now, one of the areas is in what we call structural health monitoring, where we're trying to look at assets like bridges, buildings, roads, anything like that, and we're monitoring the condition of those structures under working conditions. So rather than sending someone out once a month to survey cracks or to use a rebound hammer or something like that to measure compressive strength of concrete, or to look at if there's any rust occurring on bolts or whatever it may be, you can have sensors measuring things like stress and vibration and temperature and looking at the various working parameters while the system's in operation, and that data sending data back 24/7. So that could be on anything from our bridges or our rail systems, where we're looking at sensing the sensors in the tracks and sensors in the wheels as they're traveling, through to sewers, and we've got systems for looking for blockages and things like that, and 24/7 recording data and sending that back to the cloud so that things can be actioned based on that. For example, preventative maintenance. Smart cities are another area in terms of where IoT systems are used in an engineering sense. Here we can have a whole lot of sensors measuring things like rubbish, measuring things like lights, collecting and analyzing all sorts of data and making decisions based on that. Decisions on maybe reconfiguring parts of the city, looking at infrastructure and trying to reduce congestion, maybe changing how traffic lights are orientated or changing how traffic lights change over time. Maybe detecting traffic lights or street lights that aren't working before the complaints come in or before an accident occurs on them. I've mentioned detecting whether bins are full or not and scheduling council operations around those sort of things. So we've got chances there to increase efficiency, increase safety, and potentially reduce our costs as well. Also, we're looking at things like tracking assets through a city. Where are all the garbage trucks? Where are all the civil engineers' vehicles? Where are all the sensors being used? We can track all those sort of assets as well. Which leads into intelligent transportation systems, where we can monitor and evaluate and manage our transportation, not just road, but also things like rail and our light rail tram systems and our buses and things. Where are they all? Where are they being held up? Where's congestion occurring? Where's peak hour occurring? Using smart sensors on cars to detect rough patches, like detecting potholes and things like that. Using cameras, using cars with GPS, using predictive maintenance on vehicles. Does this car need an oil change, or is there a rattling occurring and we need to do something on this particular truck? So using all the real-time data with things like congestion and roadworks and school zones and things like that, we can reroute traffic using things like Google Maps or Google Navigation. We can work out what our best path is, and we can work out more accurate time of arrivals. Finally, we'll look at IT applications from a safety perspective within engineering. We could, for example, put IoT nodes on all our vehicles and all our people as wearables within an environment, particularly a dangerous environment. For example, there's this hard hat here where you can have a whole lot of integrated sensors in there. Things like movement sensors to make sure people are actually moving about and they haven't succumbed to dangerous gases and dropped dead, for example. Fall detection, people may have tripped over something, and if there's no one about, people won't know about it. That gas monitoring I mentioned previously, if they walk into an area where there might be a dangerous buildup of gases, but people don't know because they can't smell them. Doing location monitoring, and that can be really important. For example, if there's an evacuation, you want to make sure everyone's out of the danger area and that they're all accounted for. Measuring things like temperature and humidity and heart rate and sweat, you can work out, are they getting too fatigued, or is sunstroke a risk, or is someone fallen over and do they need assistance? Are vehicles in the place that we expect them to be, or is there a collision that's going to occur? So with these applications, we can start looking at trying to prevent accidents or collisions or various mishaps or dangerous situations before they actually occur.